Yeah, it's your boy Chill here. Welcome back to C++ Game Engine Infrastructure. We're continuing on with our logging utility. Now, I did some minor chores off screen, so let's take a look at that. Fixed a problem with missing virtual destructor and some initialization warnings. I added some nice, convenient functions here to set the level of the log entry together with its string, which turns this code into this code, a little bit shorter, a little bit easier to use. And finally, I did a little experimentation with the Microsoft unit testing framework. Before, we couldn't use R equal for our enumerations. We had to do is true. But if you supply this template specialization, a lot of gobbledygook, the important part is that your type name comes in here and then comes in here. And then you give some way of converting that into a string. Then you are able to use R equal, and you will get a very nicely printed diagnostic telling you what the expected value was compared to what you actually had. Now, one thing I kind of forgot to implement here was the timestamp, but that's not too difficult, right? We can go into entry builder. And in here, we'll just do dot timestamp is equal to std chrono system clock now. And that is good as done. Now, the main task that we have before us today is to implement the rest of the bare bones of our logging system, which means the channel, driver, and the formatter for the driver. So let's start with the channel. What are the jobs of the channel? Well, I mean, the main one is it has to output the entries that have been submitted to it. It has to output them to each of the drivers that are attached to the channel. Now, there's a lot of other things that it could do. For example, we could run the channel. We could give it its own worker thread so that it's not stealing time from, the thread that's doing the submission, right? If we give it its own worker, we're probably going to have a queue in here. And so then there's going to be logic for in-queuing entries and doing it in a thread-safe manner. The other thing we're going to apply is policies. So the channel will have to go through an array of policies and use them to transform the submitted entries. But we're going to add this feature in later. Still need to do a little bit of thinking about it. Now, the last thing a channel might be able to do is if we're doing synchronous, without a thread, there's going to have to be, because we have multiple threads submitting to a channel, there's going to have to be some kind of a mutex somewhere. So we could put a mutex in the channel, but I'm thinking it's probably better to put the mutex in the driver. So we're not going to do that either. So the only thing we're going to need is the array of drivers, the ability to add drivers, and then, looping over each driver and submitting. Now, remember I said I wanted basically one source file per class. And I'm going to bend that rule a little bit here. And in the future, what I'm going to say is if there is a base implementation and then there's an interface, they would go in the same source file pair. So channel is the base implementation of iChannel. And so we'll put them in the same source pair. Now we're going to hold our drivers as a vector of shared pointers. So I'm going to do this here. Let's see. Let's put in the data right here. So we're going to have our vector of drivers here, and we should probably forward declare iDriver. Now we're going to need a way of adding that in there. We could do it in the constructor, but I like the ability to do it afterwards. So we're going to add to the interface virtual void attach driver. Probably want a semicolon here as well. And now I will proceed to add the source file. Now it looks like this. We'll go back into channel. All right, what do we need? We need our constructor. I'll allow you to also initially supply a vector of your driver pointers, but you don't have to. The other things we need to do is we need to implement those virtual functions. So let's implement all pure virtuals. Get this out of my face. Now, Visual Studio does a very cool thing where it makes them private for some reason. But yeah, you do you. You do you, Visual Studio. We want to implement this one as well. Create the definition. Okay. All right. So now we got to implement all this stuff. We need to actually know, well, we don't actually need to know what entry is because we're just forwarding it. But we do need to know what iDriver is, and we don't have that yet. So add new item, header file, driver. So I'll just paste in from iChannel. We don't want this. We do want a forward declare entry. We don't need this yet. This should be iDriver. Yes. No, we don't need attach driver. Now, we do want a function submit, but we're going to take it in as const because we don't want individual drivers to mutate the entries under our feet. So if a driver wants to mutate an entry, it has to make a local copy. All right, so now we have this. We can include the definition of driver.h, and this should allow us to implement stuff. So this one is quite simple. We're just going to move. Nothing much to say about that. Submit, we loop over drivers and submit. So we'll do for each driver pointer in our vector. We're going to do p driver pointer to submit the entry E. And attach driver, obviously this one is also easy. Let's give it a name, p driver. And then we'll just move. Yeah, so we just move that pointer into the back of our vector. Okay, so we've implemented this. All right, so far so good. Now we want to make some tests to, verify that it works the way we expect, except I don't want to put all the tests for all the logging stuff in here. I want one file per component that we're testing. So I'm going to do a little bit of a refactor of the test code and I'll be back. So you see I've added filters here. So IOC and log. And now for the namespace, instead of doing namespace infrastructure, I'm going to do namespace equals the name of the subsystem. So we'll have one namespace for IOC, and then we'll have IOC container tests and IOC singleton tests. And then in log, we have log entry tests. Now we need to fix something here because we've added to the iChannel interface. We need to implement that. Override that with a null implementation, and that should actually build. Let's see if this stuff builds. All right, so now you can see we have the root unit test. In there we have IOC and log. We have IOC container test, IOC singleton tests, and we have log entry tests here. Beautiful. If I run these tests, I expect them to fail. Why? Because this line entry stuff, whenever you modify the code above it, the line entries become invalid. So we're just not going to test line entries. That was fun, but it's too brittle to maintain. So we'll remove that. We'll only be checking the text and the level of the log in our tests here. And that works fine. So now let's add a test for the log channel. So we'll include driver.h. What else? We'll keep the entry builder. Mock channel. We don't need to mock the channel now because we're testing the actual channel, but we do need to mock the driver. So we'll change this to iDriver. Submit is a const, and this actually can stay the same. This is not necessary. We'll keep this in here, and now it should be log channel tests. So we'll have one test here that just tests forwarding to driver. We'll actually forward to two drivers here to make sure that it can broadcast properly. So we need to create the channel. That's just going to be a log channel now. And then we want to attach some drivers. So let's make some drivers. So we'll make a mock driver 1 and a mock driver 2, and then we can attach those with chan.attach driver p driver 1 and 2. Let's use our new sexy logging syntax there. And now we want to check both drivers to see that they got the right information. So this should be p driver 1 pointer to entry. And we'll do the same stuff for p driver 2, and this should be good to go. So let us run all tests, and that should recompile. All right, so now under log, we have our log channel test, test forwarding, and here we have our entry tests, and yeah, everything is good. I might, stuff like this, maybe even stuff like this might be pulled out into like a header or something, but right now we'll just copy past it for giggles and sharts. All right, so that's a basic implementation of the channel. Let's move on to the driver. Now, unlike channel where there's a clear default in my mind, I don't think there's a clear default for driver. So I'm actually going to put a separate file, MSVC debug driver, # include driver.h. We don't need that, and then we'll do MSVC debug driver, public iDriver. There you go. Submit, override, private, memory, and we'll do a std unique pointer to an class iText formatter. So a simple formatter that will format entries into, serialize them into a text format. So iText formatter, P formatter. All right. And again, similar to the channel, will allow you to pass in the formatter. This should be an underscore, right? And you'll be allowed to pass this in, but you don't have to. You can set it afterwards. So I'm just thinking, like, some drivers will not format to text. For example, imagine a driver that outputs to a database. It's probably not going to serialize every field of the entry to a single text string. It's going to put the entries into different columns in a table, right? So what we want to do here is specialize iDriver with iText driver. So this will be any kind of medium that serializes to text, which could be, like the output debug window, or it could be a file, something like that. All right, so now we don't need this. So this is going to be public iDriver. And in addition to submit, so here we'll put the iText formatter will now go in here. Include memory here. So we'll come back here, unique pointer, iText formatter, P formatter. So we can set the formatter. Let's do like that. There we go. So iText driver specialization that will be serializing to text string, and so it will take in a formatter. So now it should be inheriting from iText driver, void set formatter. So here's the interface for the debug driver. Let's also make an interface for iText formatter. So here's the basic interface for the formatter. Now we need a CPP file for our MSVC debug driver. So now we go ahead, we create these definitions here, create definition. All right. Move in the formatter. Here we can set the formatter again by moving. And here's the actual work that the debug driver will do, which is fairly simple. Now I believe that we need to include Windows for this. We'll have our own custom Windows header at some point, but right now we'll just include Windows.h and to do replace with custom Windows header. Now, here we go. So submit. What do we do? Well, it's possible that the P formatter might not even be set. So let's do if P formatter. Then we can do output debug string W. P formatter underscore pointer to. We don't have that. Easy enough. Include for text formatter. Dot format entry E, which should be here. Dot C string. And there's Bob is your uncle. Now, the question is, what do we do if the formatter wasn't set? Well, normally in a situation like this, we would like to log a warning or something, an error, to alert the developer of this problem, maybe even an assertion. But how do we log from our logging, right? Because if this problem exists in our default logging channel, and then we have a problem, we want to log to the channel that has the problem that can't log. You know what I'm saying? So we have to think about this. To do how to log stuff from log system. We need some kind of like a fallback, simpler log that can work when our primary log isn't built yet or isn't functioning properly. We might even want to extend that to channel.h, right? Because what happens if we submit to a channel that has 0 drivers? Well, nothing happens, but maybe we want to alert somebody of that situation, like, hey, is this really what you want to be doing? So yeah, we'll have to think about that. But anyways, so we want to test out the debug driver. Now, the thing about writing tests for this thing, like, it's easy to write a test for, like, say, the channel, because the channel has a defined input component and it has a defined output component that we can mock. We can mock the driver. But what's the output of the driver? Well, it goes to output debug string W, which is not very easy to, like, mock or inject. So I'm not even going to bother testing the MSV debug driver. I'm not going to bother. Testing for this log stuff in general, it's not a critical system. If it fails, if it doesn't work properly, the program will still run properly. It only outputs diagnostics for developers mainly. So it's not critical, and the final output of this whole system is just to the developer's eyes. So it's not as easy to test as some other things would be. So we're not going to worry about fully testing everything, but I do want to verify that it works. So first things first, let's make a default text formatter. So text formatter has no state or anything, doesn't need a constructor. We just have to implement the format function, which should be quite simple. And let's just make a simple formatting. We'll include format header. And we're going to return std format. There's our format string. Now, let me see here. We have to look at what are all the things that entry has. Well, let's start with the error level. So we'll put a little inserter in here, and then this is going to be, let me see here. So get level name. So the first thing is get level name. e.level. There we go. I put the @ in front just to make it easier to grep. If you have a big long log, you want to grep for a warning, you can do @warn, and that'll make it easier to find in theory. Next thing, let's put in here, let's use curly braces for the timestamp. So I'll have to escape those curlies and then the curly inside here for the insertion. And we'll put these each on different lines just to make it easier. All right, so now here's the thing about the timestamp. If you just output it the way it is, you'll get UTC time, but you probably want time in your actual time zone. So to do that, we do std chrono zoned time. And this is something that I think this is quite fairly new to the standard library, but it took me a while to figure it out. But once you figure it out, it's actually pretty easy. Std chrono current zone to get the current time zone, and then e dot I think I've broken IntelliSense somehow here. E dot shit. All right. E dot timestamp underscore. All right. E dot timestamp underscore. Yeah, that's how it works. So you create a zone time based on the current time zone and then the timestamp that you had recorded. And that works fairly nicely. So now we have the timestamp. Now let's output the actual note here, and then I will do e.note. And finally, let's say where we logged from. So I'll hit a new line for this one. New line, and let's maybe indent it a little bit. And we'll say at function name in file name, comma, line number. Let me see here. Source function name, e dot source file, and then e dot source line. There we go. Okay, so here is our text formatter. Now this is something that I believe we could test. We could test it by constructing an e, but setting the timestamp to something that we have a bit of control over, maybe. Okay, apparently this isn't the correct way to escape. Maybe we need like a double. So that means that we'll actually end up with triple, but whatever. And here, yes, this is the thing that I always do. No no surprises here. And this is exactly why we have the static analysis. All right, builds with no errors. Let me just whip up a quick little test here. All right, so we're manually creating an entry here, and then we're just testing to see if that's equal to some expected formatted string. I haven't decided that yet. I'm just going to copy whatever it spits out, as long as it looks good. So let's see if we can build this. You can see, by the way, I removed all of the mock and everything stuff because we don't need it. Very simple test file. Let's see if we can run this test, and it's going to fail, obviously, because, you know, the expected string is garbage. Actual at info 1997 GMT +9. Yeah. And all right, so that looks about right. Let me just it's not gonna let me copy it. Oh, I gotta copy from here, I guess. Let's see here. Actual, yeah, at blah 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 blah. There we go. All right, but it does look okay. We don't want that. We don't want the stuff inside the angle brackets there. Okay, so we'll take this out. We'll put that in here. We will replace this new line. It's too much white space. I think there was only 2 or 3. I don't remember how much I indented it. But it's probably something like this. Okay, now these backslashes are going to cause us a problem. All right, and now the test works. Why is this all messed up? Yeah, that's a little better. Good. Okay. Yeah, so this is the format that's spit out from here. And interesting to create the timestamp here. You do std chrono system clock time point. So we create a time point that's compatible with the system clock. And one of the constructor just takes a duration from the epoch, which is probably like 1970 or something. I don't know what it is. But anyways, so I just went 10,000 days after the epoch. And it's pretty easy to understand when it's written out like this, but it's kind of hard to figure out how to do it when you look at all the template types and everything. Because, you know, std chrono duration, and then they got like a std ratio in there, and it gets a little messy to figure out. But once you figure it out, it's clean and it works well. Now, the last thing I want to do is I want to verify that it all works with my own eyes, and we're going to use our separate console sandbox to do that. So we're just going to do a little bit of hackety-wackety in here. All right, so we include all the stuff that we're going to be using from the log system. We got our macro in here, and I've actually added the default channel to the macro because that's how I'm going to be using it in the end product. So we create our channel, and that takes in an array of drivers. So there we go. So we create it all in one go here. We create the channel, we pass it a vector of drivers, which only has one driver, the MSVC debug driver. We make shared with that, and we pass it in a text formatter that we make unique to do with. Good. So now all we got to do is log something. So we go chillog dot. Let's have some fun with it. Fatal. And oh no's. There we go. We'll return 0. Okay, let's see if this actually works. So we're going to build it. Actually, I had to specify here that this is a vector of shared pointer to iDriver. And then it works fine. Now, if we run it, here we go. In our debug output window, we have @fatal. We have the timestamp. We have oh no's, and then we have the place where it all went wrong. We'd probably want to put a new line after this here, but there's also one cool little thing, a little trick I want to show you guys at the end of this video here. So text formatter, we want to put a new line at the end here. Now, a very nice thing that you want to have in your output windows is the ability to double click on something and for it to take you to that place in the source code. This doesn't do that for us, but you can make it work for you if you know the secret formula. The line must start with the file path. So let's do this indent. We'll get rid of this. Now what we're going to do is we're going to do a new line after the function name, and then we're going to do 2 for the original indentation, and then 1, 2, 3, so that it all lines up. And we get rid of this in, so we just have the file name, and then after the file name, you do parentheses, and you put the line number inside there. And this will allow the output window to jump to that source file. So let's see if that works. We're going to run it. This will likely break our test here, so we should probably redo our tests. But yeah, so now we have this here, and it says fatal blah 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 at function name main in this file. And if we double click, boom, it goes right to the line that generated this log. And this is super useful. Such a simple thing to do, but once you know the secret sauce, it supercharges the user experience with your logs. Just put it that way. All right, so that is that. Now let me quickly run the tests again. All right, so yeah, the test format test fails because this should now be... All right, and now it is working. We're all green on our tests again. Everyone's happy. And there you have it. We are done for this video. So now we have our simple channel, driver, and formatter. And we got some tests up in there. And I showed you the cool trick with the line number. It'll let you jump to your source code from your output window. In the next video, I want to take a look at our log levels and just have a little discussion about what each level means and when to use it. And until then, thanks for watching. Hope you enjoyed this video. If you did, please click the like button, helps a lot. And I will see you again with some more C++ game engine infrastructure.